Alright, Math 1. Here's a warm-up. It was on page 57. Okay, if you haven't had time to do this, then pause the video. We got plenty of time, and you can get working on this, trying this on your own first. Okay, so pause the video and get this on your own. Alright, so let's take a look at this warm-up. So, a local dollar store sells goods for around $1. The name is a little misleading these days with the rising cost of goods. You have kept track of the number of items you've bought and the prices you paid for the number of goods. You recorded your data in the table below. So the first thing it wants us to do is to plot these points. So we plot the point 2, 5, 4, 8, 9, 14, and 10, 19. Okay, and it should look something like that. Okay. Alright, now it didn't want us to, but if we were to go further, we could then try to say, well, what would a line of best fit look like? Would it look like that, or could it look more like that? Okay, a linear or an exponential. Which one would model the data better? And we could take a look and put it in our calculator and go with that way to really get a good idea of where it would be. So, let's take a look at that. So, in the calculator, remember we would start a new document, do the lists and spreadsheets, have the number, the cost, put our information in, open up a new Data and Statistics tab, choosing our variables here, and we'd get those points plotted, okay? Then we'd go menu on this one, analyze, then regression, and we'd use both of those to see what kind of regressions we would get. So that's what I'll do, and then I will take a screenshot of that so we can see what that would look like. Now remember, you have those instructions about how to make a scatter plot. And if you don't, they're over where you get the homework, in case you weren't here last time, or the time before when we got them. Okay, so let's see what we get. So here, sorry about that. So here we have our table, right here, goods, cost. Put that table in there. Go to the second screen, choose goods, choose costs. Then we hit menu, like I said, analyze, regression, and I did both the linear and the exponential. Okay, you can kind of see them side by side, but this is the exponential. So we can see that with the exponential we start with about 3.9, about a 4, and we're growing by 1.16, so about 16%. Okay, it follows those pretty well. Okay, the linear does pretty good at the beginning as well, with a y-intercept of 1.65 and then the slope of about 1.58, 1.6. Okay, so it looks like it starts out pretty good, but then we're a little off on these ones, whereas the exponential seems like it's fallen it better. It'd be interesting to see where the next point was. That'd probably be the best way to really judge which one would be better. Alright, question 2. Alright, Yasin is a welder. For his job he requires 1 hour to set up and then 3 hours for each project. The time it takes on his job to complete X project in 1 day can be modeled by the function y equals 3x plus 1. Graph the function y equals 3x plus 1. So, not too bad, right? If we remember how to graph, we can use a graphing calculator or Desmos. But in this case, it's in that slope-intercept form. So y-intercept of 1, slope of 3, which we put a 1 under it. So up 3 to the right 1. And we keep going in that same format. Now, it wouldn't make sense to go to the left or below because negatives wouldn't make sense in this situation. Okay? And there we go. Okay, so you should have already done the daily check. We should have our workbooks open, page 57. Let's turn over. Let's take a look at a few examples. So kind of what the plan is here. I think we've got about 3 examples we'll talk about. And then we've got 2 problems from the homework, or like 2 tables. So we'll give you some time to work on those and kind of talk about those as well. So it says Andrew wants to estimate his gas mileage, or miles traveled per gallon of gas used. He records the number of gallons of gas he purchased and the total miles he traveled with that gas. So we've got the gallons, miles he traveled. It says create a scatter plot showing the relationship between gallons of gas and miles driven. Which function is a better estimate for the function that relates gallons to miles? Y equals 10x or y equals 22x. How is the equation of the function related to his gas mileage? Okay. So first thing we need to do is, using this data, create a scatter plot. Okay. Now, we can do this by hand, or we can use the calculator. I would suggest we use the calculator because it's just much easier. So let's do that. So you get out your calculator, and you should be going along with me on this. Okay. You create a new document. You do the lines and spreadsheets. Lists and spreadsheets, right? So new doc. Okay, so once again we did new document, then we go down, do lists and spreadsheets, or data and statistics, either one first. Then, once you got the one, you hit control, you just press it once, you don't have to hold it down. Then you press doc, okay, then you choose the other one. So if you did data and statistics first, do list and spreadsheet, or vice versa, okay? And get those, and then we're going to need to, in the list and spreadsheet, enter in our data. So you have this workbook in this example in your workbook, so by all means use those numbers, okay? But remember, up here in the label, I just did gallons and miles, and then I matched them up as they are in the table, okay? So once you get that all typed in, and if you need some extra time, ask the guest teacher to pause it for you for a little bit. Okay. But you get that typed in to that list and spreadsheet. Okay. Now, once you've got that done, you go to your other document, the data and statistics, right? From the data and statistics, okay, once you got all your data in there, you'll see the points. You'll add the variables. So make gallons, the bottom one, and miles, the top one. Then you should see a scatter plot that looks something like this. Okay. Now, it wants us to graph y equals 10x and y equals 22x. Okay, now what happened is I graphed those points, and notice that I'm not on my x and y intercept, or axes. These don't go all the way to 0, okay? But the way you plot a function is you hit menu, then analyze, then plot function. It'll have a little box and it'll say like f1 of x equals, and then we put in our functions 10x and 22y, okay? And I could see one of them, but I couldn't see both of them, okay? So what I realized is my window had to be adjusted. So if you hit menu again, go to window zoom, you can try to zoom out, but it's not that easy. So if you go window settings, instead, change your x min and your y min to zeros, x max about 20.5, y max about 500, okay? You can do that, and then you'll get a better picture for your graph, okay? So one that will be easier to look at, okay? So I'll get that one up here. Make sure you get your window set again. Okay, so it should look like this now. Okay, now if you'll notice we have 0, 0. So all our data was concentrated up here, but we've got these 2 lines. Now if you click on the line, This one would be y equals 10x, or f of 1, or f of 2. This would be y equals 22x. Okay, pretty obvious which one follows the data more. It's y equals 22x. Okay, so then we could use that to estimate, to say, what if we had 10 gallons? About how far would we go? Okay, if we had, depending on where we wanted to go, that would be a better estimate than 10x. So what does that mean? Okay, so that means y equals 22x, okay, to have a y-intercept of 0, y-intercept where it would start, no gallons of gas. Are you going to go any miles? No. So 22 over 22x is like 22 over 1, so it would basically mean 22 miles per gallon of gas. So his vehicle gets 22 miles per gallon. Okay? There's our first example. Example 2. The principal at Park High School records the total number of students each year. The table below shows the number of students for each of the last 8 years. Create a scatter plot showing the relationship between the year and the total number of students. Show that this function is a good estimate for the relationship between the year and the population. Approximately how many students will attend the high school in year 9? Okay, so now we're going to try to use this to estimate things. Okay, so first of all, we want to take that data and put it into our calculators. So pause the video if you need to get those into your calculator. So you put all those in there, and it should look something like this. Okay, now notice again, my scale doesn't go down to 0 on the y. Could I adjust it so it could? Yeah, I could. Now it wants us to take that and input that equation. So again, once we've got this in here, we hit Menu, Analyze, number 4, Plot Function, and then I'm going to type in my function, which would be 600 times 1.05 to the x. Okay? And when I type in that function, this is what we see. Okay, so looking at this, looks like it's a fairly good estimate. Okay, I'm a little worried about that right there, that we're getting off. Okay, so it's not quite going up maybe the same way we anticipated, because our line, see how our line keeps going this way? If we use that line to estimate for year 9, because x is years, I could type in my calculator like this, 600 times 1.05 to the 9th. Okay, if we do that, 600 times 1.05 to the 9th, that gives us 930.797. So 931 students, which, see how that in year 8 we already had 930. So maybe that wouldn't be the best, okay? However, if we go back and we, on our graph, and hit Menu and do a regression, let's see what, and do exponential, let's see what the exponential regression gives us, what equation. So if I do that, we get, looks like this, okay? So with an equation, it looks like that. Okay, see how it's going up a little more? So if I type that into my calculator for the 9, so I go 589.057 times 1.0546 to the 9th, end up with 950.48, so 950 and half a student, okay, which probably is a better estimate than the 931, okay. So the calculator can give us a better line of best fit than just trying to guess at one. Alright, example 3. The weight of oranges vary. Maria wants to come up with a way to estimate the number of oranges given a weight. She weighs oranges and records the weights in the table below. Good job, Maria. says create a scatter plot showing the relationship between the number of oranges and the weight in pounds. Is a function y equals 0.6x minus 0.5 a good fit for the data? Maria has a bag of oranges that weighs 2 pounds. Approximately how many oranges are in the bag? Okay. So, if we're looking at this, once again, you need to pause this so that we can figure out, type in the information, put it into the calculator, and go from there. So you want to enter all this into your list and spreadsheet again. Okay. So if you need a pause so you can do that, by all means, have your guest teacher pause it so you can follow along in your calculators here. Okay. And I made a mistake, dang it. There we go. Gotta make sure you type it in well so you don't mess things up. Because if you do, that throws off all your data. Okay, so you get that in. You set up your graph again. For oranges and pounds. Okay. And you end up with a graph that looks like this. Alright? Okay. So then we want to see that 0.5 and 0.06 to see how good that is. So I'd go to my calculator, go menu, analyze, plot function, and I type in 0.6x minus 0.5, hit enter, and we see what that gives us. And we get this right here. Okay, does that look like a pretty good estimate? I mean, that's decent, not too bad. If we really wanted to, we could go to the calculator, hit menu, analyze, regression, do a linear regression, and see what equation we come up with in our linear regression. Now this one on the left, this is our linear regression. Notice that the slope is pretty much the same and the y-intercept is pretty much the same. So not much different in terms of whether we go with the one they mentioned or we go with a different one. Okay. So it says, was it a good fit? I'd probably say yes, it's a good fit. Okay. She has a bag of oranges that weighs 2 pounds. Approximately how many are in the bag? Well, we could look graphically. If we go up to 2 and then over, okay, it's probably going to be like a few. Or we could use the equation and put, let's see, x is the number of oranges, isn't it? So I was going to the wrong number. This 2 is pounds. Looks like pretty close to 4. So if we use the equation to figure that out, the y would be 2 pounds. So we'd add 0.5. So I get 2.5 equals 0.6x, divide by 0.6, and that would tell me approximately how many we had, which is about 4.166661, and then 6 repeated. So yeah, so approximately 4 oranges in the bag would be a good guess. Okay? Alright, so why don't we give you guys some time to work on this. Let's not worry about this. Actually, yeah, let's take a look at this one. So word of mouth can be a great way to increase a movie's popularity. Okay, so they've got 2 situations here. Well, one situation. The days, number of viewers. Okay. And then we're trying to determine something to fit it. So we've got an exponential and a linear. So let's see the difference. And they also want us to say about how many people should see it that day. Okay? Alright, so I put all the data in. Okay, went and graphed it, and we look at this. you should see right off the bat that this is a very, that's curved pretty well. So most likely our linear, as we can see, doesn't take into account that very well. And as we keep going, the way this is growing, it looks like it's going up exponentially. So if we see the exponential, that's definitely matching it almost like perfect. Okay? Probably is perfect. So to figure out on the 5th day, we just plug in 5 for x, and we get there's probably going to be 3,125 viewers according to that. Okay? So kind of that difference between linear and exponential depending on the data. Now the data could have been more linear. Just depends on the data. Okay? So here's what you're going to do now on your practice problems. Okay? I want you to finish these in class. So what we're going to do is you've got the calculators. You've got a table. So you'll take the table, create a scatter plot, decide is linear or exponential going to be better, estimate for the data. Okay? Then you're going to put those functions in to see which one looks better. Okay, and then try to approximate some information. Okay, you'll do this first problem. Okay, then you'll actually do the second problem. So give yourselves about 10 to 15 to 20 minutes. Okay, I want you answering all these questions. This page needs to be tore out of your workbook and handed in. It'll be graded when I get back to school. Okay, so this worksheet needs to be handed in, ripped out of your workbook and handed in. Okay, so now using the calculators, make sure you answer these questions and hand it in. After that, we can take a look and see how you did. Okay, so have the guest teacher pause the video. You guys work on those problems, and we'll go from there. Actually, let's do it differently. Let's have you guys just work on this for the rest of class, and then hand them in. And when I get back, I'll hand them out, and we'll talk about it, and we'll go from there. All right? So I expect this practice to be done in class. It needs to be handed in. There will be no video online for it. So get this handed in, and then when we come back next week, we will talk about it.